Okay, this is chapter 6, day 12. Um, and on this is where I do a quiz. I have an old quiz. This used to be chapter 8 in the old book. So that's why I call it old quiz 8.1. It's pretty cool though. So we're going through the binomial distribution. And like I always say, stop this video whenever you need to. Maybe you do the problem ahead of time and then use my video to check over. It's really up to you. But even though this will be a quick video, you need to pause it constantly, and I'll try to be as thorough as possible. Okay. So let me read the problem to you. What do you think is the ideal number of children for a family to have? A Gallup poll, we use Gallup poll a lot or refer to it a lot, very reputable organization, polled to ask this question of 1,006 randomly chosen adults. That's a weird number. They probably were just going after 1,000. Whenever you do 1,000 or 1,500, you get a margin of error of about 4%, which most people can tolerate. That's why that number exists. We haven't studied that yet because that's coming in subsequent chapters, but that's why they use that number. Okay, almost half, 49%, thought 2 children was ideal. Makes sense. Suppose that P, the actual percentage, is 49 for the true population of all adults. Let X be the number of adults who thought that 2 children was ideal. All right. Is X binomial? All right, we've talked about, I gave you an acronym of POTI, P-O-T-I, with P being the probability is consistently the same. Now, in something like dice, rolling a 6 is always the same 1/6, and flipping a coin, getting heads, is always 0.5. Sometimes you have to just accept the fact that it's going to be pretty consistent. Okay, like free throw shooting, if somebody is an 80% free throw shooter, then P is a fairly consistent 0.8. What you got to look out for is in non-replacement situations, where when you have non-replacement in a small sample size, you definitely are changing the probability all the time. That would not be binomial. Now, when you're dealing with this, I know we're not random, we're not talking to the same person twice, so there is non-replacement, but you got so many people here that pulling one out doesn't effectively change the probability. So that's a long explanation for the P in POTI, meaning the probability is an assumed 0.49 that a random person will answer to. Pretty consistent. All right. The O in POTI is outcomes. There's got to be just 2. And in this case, it's people believe that 2 is the ideal number of children or some other number. We just group them into one set. T is trials, and there's 1,006 trials. And then I is independent. We're assuming that everyone's response is independent. These 1,006 people are unlikely to know each other, so yeah, they're independent. All right. Next one, find the mean and the standard deviation of X. Okay, number 2. All right, and there's the math. The mean is just N times P. So it's literally 492.94. I'm going to round that to about 493, somewhere about there. And then the standard deviation is N times P times 1 minus P. And 1 minus P is often called Q. Okay, so this is often called Q. I wrote that in red there. Often called Q, or 1 minus P, that's fine. It's about 15 or so. So these are the 2 important numbers there, all right? Then find the probability that X is exactly 493. So even though 493 is the mean number of people out of 1,006 that would say that 2 is the ideal number of children, it's not super likely you'll get the exact mean. It's kind of like this. If you flip a coin 10 times, the mean number of heads is 5. The chances of you getting exactly 5 out of 10 is pretty good because it's a small sample size. However, if you roll or flip 100 times, the mean is 50, but the chances of you getting exactly 50 is less because there's just so many options. Same thing here. So even though 493 is the mean and is the high water mark for any other outcome, it's not super likely to happen. On your calculator, it'll be that. I wrote this out for you as well because it might be good to know that notation. Remember, this is 1006, choose 493, but the notation is often written like this. I believe you should write that down and know that, because sometimes on the AP test, they won't give you the answer like this that I circled, but rather they'll write out how to do it, and you've got to identify that. So this is 49% happened 493 times, and the 51% happened 513 times. Okay, so let me clear that. We're on to number 4 now, circle number 4. Find the probability that X is within 2 standard deviations of the mean. What I did is I took the mean and then I went plus, or I forgot the minus, plus or minus 2 times 15.86. And I got these barriers somewhere between 461.22 and 524.66. But I know it's whole number answers because there's not a partial person. So somewhere between here and here. Now, to get the area between there, we've seen this in class and other videos. You've got to figure out the area less than 525, including that. So the area less than 525 with binomials is 1,006 trials, 49% chance, 525. Then you've got to subtract the area below 461, which is actually starting at 460. And that should leave you between 461 and 525, and including those two numbers. Comes out about 95%, 96% basically. Okay, which makes sense, because within 2 standard deviations of the mean should be about 95%. We'll get into that later. But that's literally how to do that question using binomials. This is a discrete random variable approach, meaning a countable number of outcomes, and I'm literally counting every single outcome and doing it exact. That's the exact answer. All right. Next, I'll screw on number 5 here. Hold on a second. Right. That's good, right there. All right, so number 5, describe the distribution. Remember, that's going to be cuts, if you recall, describing the distribution. Now, I didn't put any unusual features because there really wouldn't be any outliers in this situation. So center shape spread is fine as well. The center is 493, that's the mean. The shape is approximately normal because we have a large sample size. And the spread could be range, IQR, or standard deviation. And I chose standard deviation because it's really readily available. The spread is a standard deviation of 15.86. All right. Would it make sense to compare your answer in question 4 to the empirical rule? Oh yeah, no question. So check out our answer in question 4, okay? And the empirical rule says that 95% of the observations are within 2 standard deviations of the mean. So yeah, sure, okay? Now we're going to do a normal approximation for this between those at area, those 2 numbers that I did binomially, okay? And I'm going to do it the shortcut way. I'm not going to get the z-scores because I know the z-scores are -2 and +2. I know that because they're within 2 standard deviations of the mean. I'm going to do it the way I showed you in class, where I'm not going to convert to a z-score. I'm going to keep it in raw score form. So in CDF, there's the lower end, there's the upper end. The mean is that, the standard deviation is that. That will circumvent the need to get z-scores and lead me right to the answer. Look how close those are. The normal approximation to the binomial is much easier to work with, and it produces essentially the same answer. Okay? And question 8, of course, asked that. Why are they so close? And then I wrote a good answer for you to remember. We use the normal approximation to the binomial, which works best for large samples. Pretty simple. It doesn't work well for small samples because you're turning a discrete random variable into a continuous. And if you have small samples, there are problems with it. And I showed you that in the previous lesson. Okay. All right. The next part of this lesson was a one question thing out of your book. I don't put a lot of the book stuff into my notes. I let that be the homework, but I went to the Frappy. Remember, that's the free response AP Yay. Okay, kind of a thing, pretty cool. And I just rewrote the question. Okay, so here it was on page 414. Buckley Farms makes homemade potato chips that sells in bags labeled 16 ounces. The total weight of each bag follows an approximately normal distribution with a mean of 16.5 and a standard deviation of 0.12. That's, pretty standard. If you select one bag of chips, this is question A, what is the probability that the bag weighs less than 16 ounces? Okay, so question A, I can do that real quick, right there. All right, so let's check this one out. I'm gonna do this question is actually from chapter 2, is this question. It's question A right there, okay? Chapter, that's pretty bad right there, chapter 2. Okay, so all I did was I took I wrote out the scale here, and then I did a z-score, which is 16 minus 16.15 divided by 0.12, and I got negative 1.25. And then I used my calculator and got the area below negative 1.25 z-score, and it comes out 0.1057. So about 10 or 11% of the bags will weigh less than 16 ounces, even though they advertise 16 ounces. Okay. All right, again, pause the video anytime you need to. That's the whole point of this. Okay, question B says, if you randomly selected 10 bags of chips, what is the probability that exactly 2 of the bags will weigh less than 16 ounces? Now we got a binomial. And this binomial relies on the answer you put in question A. So if this was an AP question, when they grade it, if you use the wrong answer from A in part B, but do the process right, you do get it correct. So if you can't get A, make up a decimal and then go ahead and use it in B. Okay. All right. First thing you got to do, this is hard to remember on part B, is you need to write out why it's binomial. Okay. So you got to put that POTI acronym. And I'm going to write POTI right here, but don't put that on your tests, okay? So the probability is a consistent 0.1057, okay? There's 2 outcomes, less than 16 ounces, or B, greater than 16 ounces. There's 10 trials, and each bag is independent. Okay, fine. Most likely, you're solving the problem this way. Binomial PDF, 10. That's the trials, right? And this is the probability, and this is n. 0.1057 comma 2, and it's about 21%, 20 or 21%. The other way you can do that, remember, this is 10, choose 2. You should know how to do this by hand as well, where that is P and then the number you want there, and that's 1 minus P, and that's the total sample size minus n, okay? You should be able to do that way as well. Again, sometimes what they do, I box this, is they put those answers on the test, don't actually calculate it, and see if you know the process. That does happen, so you got to know that as well. Okay? All right. Question C. Okay? So question C is Buckley Farms ships its chips in boxes that contain 6 bags. The empty boxes have a weight of 10 ounces and a standard deviation of 0.05 ounces. Calculate the total mean and standard deviation of the total weight of the chip bags in box. No problem, okay? A little bit of work here, thinking-wise. All right, what you got here, remember, when you do the mean of things, you just simply add them. Now, what I could have done, look where the arrow is here, I could have written out 16.15 plus 16.15 plus 16.15 plus 16.15 plus 16.15 plus 16.15, because there were 6 bags of chips. But obviously quick addition is called multiplication. You learned that in 3rd grade. So it's 16.15 times 6 plus the box itself, 10. And the average of the whole situation is about 106.9 ounces. All right. Then the standard deviation is similar. I could write out 0.12 squared and add 6 of them up, but I'm just going to multiply it by 6 because there'll be 6 of those. And then plus the standard deviation of the box, and go ahead and re-square root it, and you get 0.369. Okay? So that isn't too hard. The difference there is we had so many similar terms, I just multiplied it by how many there were instead of adding them up separately. All right. And then question D. D. Buckley Farms decides to increase the mean weight of each bag of chips so that only 5% of the bags have weights that are less than 16 ounces. Assuming that the standard deviation remains 0.12, what mean weight should they use? All right, they want fewer bags coming in light because there's problems, okay? This problem is, again, a chapter 2 problem, believe it or not. We did this way back, okay? So what I did is I drew out my typical raw score, remember that? Raw score, z-score, percentile, like we've been doing a lot. So I filled in 16, and I filled in mu, I didn't know what it was, and then 0.12. I didn't have this initially, this negative 1.64. I just had 0.05, and I want the area below that. I had to do inverse norm 0.05 to get the z-score for 5%, okay? And it's negative 1.64. So this one right here that the arrow is going into, I had to do that with the calculator. Then I took my z-score formula, right? Z equals x minus mu over sigma, remember that? And then I just went ahead and did that and used algebra to calculate it, and I got 16.2, basically, 1968. Okay, so that is chapter 6, day 12, and I hope that's helpful for you. Thank you very much.